Hello! In this video, we are going to tackle solving rational equations and rational inequalities. When solving rational equations, we want both sides of the equation to be single fractions. The reason is that we want to apply the property of proportion, which states that the product of the means is equal to the product of the extremes. So if we are going to rewrite this in another form, we may write this proportion this way. A is to B equals C is to D, where B and C are what we call the means, and A and D are what we call the extremes. According to the proportion, to the rule of proportion, the product of the means, so the product of B and C, is equal to the product of the extremes, A and D. So from single rational fractions on both sides, we can rewrite the equation this way. To make sense, let's try to solve example number 1. Let's say we want to find the value of x that would make the equation true. So we may write the missing denominator of the right hand side. So we may place or affix over 1, since that would not change the value of 12. Then we will apply the rule of proportion. So the product of 3x and 1 should be equal to the product of 4 and 12. This will give us 3x equals 48. Dividing both sides by 3, we will obtain 16. So when x is 16, this equation is true. Let's check. 3 times 16 divided by 4, is that equal to 12? The answer is yes. So the answer is 16. What about example number 2? So again, the issue is that our right hand side does not have a denominator. So to fix that, we are going to affix or write over 1, since dividing a number by 1 does not necessarily change the value of the number. Again, applying the rule of proportion, the product of 4x and 1 should be equal to the product of 8 and the quantity 2x minus 3. 4x times 1 is 4x. Distributing 8 to 2x and negative 3, we have 16x and negative 24. Then, moving 16x to the left-hand side, it becomes negative 16. What's left on our right-hand side is negative 24. Now, 4x minus 16 gives us negative 12x, and that is equal to negative 24. Dividing both sides by negative 12 to cancel negative 12, we will obtain x to be positive 2. So if we are going to replace every x in the rational equation, we should have, rational expression on the left hand side, we should have 8. This is 4 times 2 is 8. 2 times 2 is 4 minus 3, that's 1. And 8 over 1 is equal to 8. Let's try example number 3. So the first issue here is that The left-hand side is not a single fraction. That's why we want to express it as a single fraction first. So we have to look for the LCD of the two fractions. And to find the LCD, we may use listing method. So we will list down the multiples of 2 and the multiples of 3. The first number to appear in both lists is the LCD. So the multiples of 2 are 2, 4, 6, 8, and so on. While the multiples of 3 are 3, 6. And we have to stop here already because the number 6 appears in both lists. So the LCD here is 6, which happen to be the product of the two denominators 2 and 3. Now that we have found the LCD already, we will now transform the two fractions that we are trying to add into new fractions whose denominators are both 6. And then we will divide 6 by 2. 6 divided by 2 is 3. The answer to that, we will multiply by x. So we will get 3 times x, that's 3x. Same here. So we will divide 6 by 3. We will get 2. And then we will multiply that by the numerator, which is also x. So we get 2x. And we want this to be equal to 5. Now that the two have the same denominators, we may now combine them into a single fraction. So we have 3x plus 2x all over 6, and that should be equal to 5. At this point, I will now place a denominator of 1. 3x plus 2x, that is 5x, divided by 6. That should be equal to 5 over 1. By law of proportion or rule of proportion, the product of 5x and 1 should be equal to the product of 5 and 6. Then 5x is equal to 30. Dividing both sides by 5, x is equal to 6. If we are going to check that, 6 divided by 2 is 3. While 6 divided by 3, that is 2. And 3 plus 2 equals 5. Therefore, the value 6 which we have obtained is correct. Now we proceed to example number 4. So again, we have the same problem here. The problem is that our left-hand side is not a single fraction. That's why we have to first find the LCD of the two. So if we will look at the numbers 3 and 2, the LCD is 6. While if we are going to look at the variables, both x's have the same degree. That's why we are going to take x to whatever their degree. So 6x. And then after finding the LCD, we are going to transform the two fractions that we are adding into new fractions whose denominators are both 6x. And then 6x divided by 3x, that will be 2. We will multiply that by the numerator, which is 4. 2 times 4 is 8. Same here. 6x divided by 2x, that is 3. The answer we will multiply by the numerator. So 3 times 3 is 9. We want this to be equal to negative 17. Now that the two have the same denominators already, we can now combine them into a single fraction. And I will start affixing 1 here. What is 8 plus 9? That is 17. So 17 over 6x, it should be equal to negative 17 over 1. Rule of proportion, the product of 6x and negative 17 should be equal to the product of 17 and 1. 6x times negative 17, that is negative 102x, while 17 times 1, that is 17. Dividing both sides by negative 102, we will obtain x to be negative 17 over 102. We may notice that both 17 and 102 are divisible by 17. So we will divide both by 17 to simplify the answer. And we will get negative 1 over 6. Let's try example number 5. Here, our minuend is a whole number. So we can write a denominator of 1. And then the LCD of 1 and x is x. So only the minuend has to transform into a new fraction whose denominator is x. Our subtrahend is not going to change. It does not have to change because its denominator is already x. Now, x divided by 1, that is x. The answer, x, we will multiply by the numerator 5. So we have 5x. And this is equal to 10. Now that the two fractions have the same denominators, we may now combine them into a single fraction whose denominator is x. I will write over 1. Then, the product of 5x minus 3 and 1 should be equal to the product of 10 and x. 5x minus 3 times 1, still 5x minus 3. This is equal to 10x. Moving 10x to the left, it becomes negative 10x. 5x stays on the left, so its operation stays the same. Moving negative 3 to the right, it becomes positive 3. Negative 10x plus 5x, that's negative 5x, and it should be equal to 3. So, dividing both sides by negative 5, we obtain x to be equal to negative 3/5. Got it? Alright. Now we try example number 6. What is the LCD of x and the quantity x plus 1? The answer, it's just their product. Then, their product will be x squared. That's x times x, so x squared. X times 1 is x. So our new denominator will be x squared plus x. Now, we will transform the two fractions into new fractions whose denominators are both x squared plus x. X squared plus x divided by x we will obtain x plus 1. And then we will multiply that by the numerator. And then this will be 2x. This will be plus 2. We'll do the same here. X squared plus x divided by x plus 1. The answer is x. And then we will multiply that by x. So x times x, this will be x squared. And then we will now combine the two into a single fraction. This will be x squared plus 2x plus 2. And we want this to be equal to 1. So if we'll I'll place a denominator here. If we multiply x squared plus x times 1, that's x squared plus x. If we'll multiply the quantity x squared plus 2x plus 2 by 1, that is x squared plus 2x plus 2. There is x squared on both sides, so we will cancel the x squared on both sides. Now, moving 2x to the left hand side, it becomes negative 2x. While x minus 2x, that is negative x. If negative x is equal to positive 2, then it means that x is equal to negative 2. So the answer is negative 2, right? Okay. Example number 7. What is the LCD of the two fractions? The answer, it's just their product. And their product is x squared minus 1. So our numerator later will be both x squared minus 1. X squared minus 1 divided by x plus 1, that is x minus 1. Multiplied by 4, this is 4x. This is negative 4. X squared minus 1 divided by x minus 1, that is x plus 1. This is 3x. This is positive 3. Then we want this sum to be 1. Combining the two, we'll have 4x minus 4 plus 3x plus 3 all over x squared minus 1. Our numerator will become 4x plus 3x, that is 7x. Negative 4 plus 3, that is negative 1. Over x squared minus 1 equals 1 over 1. Then the product of x squared minus 1 and 1, that's x squared minus 1. It should be equal to the product of 7x and 1, that is 7x minus 1. On both sides, there is minus 1, so we are going to cancel them. Then we will move 7x to the left hand side. It becomes negative 7x. Now the left hand side can be factorized. We see a common monomial factor, that is x. And if we are going to extract x from x squared, there's an x left. That means x times x is x squared. If we're going to extract x from negative 7x, there is negative 7 left. X times negative 7, negative 7x. This is 0. So if this product should be 0, then it means x can be 0 or x minus 7 can be 0. What should be the value of x so that x minus 7 equals 0? The answer is 7. So we have two possible answers here. X can be 0 or it can be 7. So 0 and 7 will make the equation true. Alright? Let's try example number 8. So I will just place a denominator or that is 1. Then I will apply the rule of proportion. The product of x minus 2 and 1 should be equal to the product of x squared minus 4 and 0. Product of x minus 2 and 1, x minus 2. Well, the product on our right hand side, that is 0. And what should be the value of x to make the statement true? The answer is 2. Now, we found that the answer is 2. But actually, this is impossible, or this is an extraneous solution. Although we found 2 to be an answer, we take note that our denominator should not be equal to 0, because that will make our fraction undefined. And look, if we are going to replace 2 or replace x with 2, then we'll have 2 squared, that is 4, minus 4, that will be 0. So our denominator will be 0. It means the value of x cannot be 2. So it means this rational equation has no possible solution. Alright? Now we go to the last example for solving rational equations. I will place a denominator 1. The product of x minus 3 and x plus 3, that should be equal to the product of x squared minus 9 and 1. The product of x minus 3 and x plus 3 is x squared minus 9. And look at our left hand side and our right hand side. They are identical. And when they are identical, it means whatever value of x, whatever value we will replace x, our statement will always be true, that the left side will always be equal to the right side. So how are we going to answer this question? What are the possible values of x? The answer is all real numbers, except the number that will make the denominator 0, and that is 3. We can make use of any real number except 3, because 3 will make the denominator 0, and we don't want it to be 0. Alright? Now we go to solving rational inequalities. So in solving rational inequalities, we will follow 5 steps. Step 1, our goal is to make the right-hand side 0. And we want to make the left-hand side a single fraction. We take note of the sign after we express the ratio. So how do we do step 1? Using example number 1, we will move 1 to the left. So it becomes -1. So what's left on the right-hand side? 0. Then we will combine 2 over x minus 1 into a single fraction. So I will place a denominator of 1 here. And the LCD of x and 1 is x. So 2 over x does not need to transform. But 1 over 1 need to transform into a new fraction whose denominator is x. X divided by 1 is x. The answer, we will multiply by the numerator. That is 1. 1 times x. So x. Now that the two have the same denominators, we will now combine them. And we want this ratio to be greater than 0. It means we want the ratio to be positive. So we take note of that. Now, after we express our inequality in such a way that the right-hand side is 0 and the left-hand side is a single fraction, we will now determine in our step 2 the meaningful values. And how do we determine the meaningful values? We set the numerator to 0 and then we solve for x. And then we do the same to the denominator and then we solve for x. So numerator 2 minus x, we set to 0. What should be the value of x so that 2 minus x becomes 0? The answer is 2. So our first meaningful value is x equals 2. While using the denominator x and setting it to 0 will automatically give us the other meaningful value. And in our step 3, we are going to use these meaningful values to divide or separate the number line into parts. So we are going to use 0 and 2 as our boundaries. That divides the number line into how many parts? Into 3 parts. The first part is from the first part is 0 below. The second part is between 0 and 2. And then the third part is x is greater than 2. And finally, we are going to use or test those intervals that we listed down in step 3 to identify or determine which of them is or are possible answers. So we list down our intervals. Then we will choose test values, a test value for each interval. So for our first interval, we use -1 since -1 is a number that is less than 0. For our second interval, we will use +1 since 1 is between 0 and 2. It is inside that interval. While for third interval, we will use 3. Then we will copy our ratio. 2 minus x over x, we want that to be greater than 0. We want the ratio to be positive. What will be the sign of our numerator if we will replace this x here with -1? So that will be 2 minus -1. That is a positive number. If we will replace the denominator x with -1, what will be the sign of our denominator? Negative. So the sign or the ratio will have a sign that is negative, since positive divided by negative is negative. Now, what about 1? What if we replace the x here in the numerator with 1? So that will be 2 minus 1. It is positive. For the denominator, we will replace x with 1. So our denominator will also be positive. And the ratio of positive and positive is positive. Lastly, if we will replace the x in the numerator with 3, then that will give us 2 minus 3. It's a negative number. While if we will replace the denominator x with 3, that will be a positive number. And the ratio between these two is negative. Again, we want the ratio to be positive. And the one that gives us positive ratio is this interval. Therefore, our answer will be x can be any number between 0 and 2. Let's try example number 2. Step 1. We want the right hand side to be 0, so we move 1/2 to the left. It becomes negative. And we want the left hand side to be a single expression. So we find the LCD of 3x and 2. And the LCD is 6x. We will now transform the two fractions. Their denominators will become, both of them will become 6x. 6x divided by 3x, that is 2, multiplied by 2, that is 4. 6x divided by 2, that is 3x. And 3x times 1 is 3x. Now that the two have the same denominators, we will now combine them. And this is our ratio. We want it to be less than or equal to 0. It means we want the ratio to be negative. We take note of that. So our step 2 will be, we will look for the meaningful values. We set the numerator to 0. We solve for x. We set the denominator to 0. We solve for x. Here, I will move 4 to the right hand side, so it becomes -4. Dividing both sides by -3. Our first meaningful value is 4/3. Here, divide both sides by 6. Divide both sides by 6, you will get 0. So in our step 3, our number line will be divided into 3 parts. Again, 3 parts, where 0 and 4/3 will be our boundaries. But we take note that the inequality symbol has a bar. It means we include the number or the value that will make the numerator 0. So this number is included. 4/3 is a possible solution. So our number line is divided, but 0 is not included. So again, our number line is divided into 3 parts. Part where x is less than 0, x is between 0 and 4/3, and x is greater than 4/3. These are our intervals. And now we go to step 4. We are going to test each interval. So we will select test values. We test the sign of the numerator, sign of the denominator, and then sign of the ratio. The test value here is -1, but you may use -2, -3, or others. Here I will use 1. But on the third interval, I will use 2. If I will replace the x in the numerator, so we go back here. If I will replace this x here with -1, the sign of our numerator will be positive. While if I will replace this x with -1, the numerator will be, the denominator will be negative, and the ratio is negative. Next, if I will replace this x here with +1, I will get a positive numerator. And then if I replace this x with +1, same, my denominator is also positive. Their ratio is positive. Lastly, if I will replace this x here with 2, then I will get a negative numerator. If I replace this x with 2, my denominator will be positive. The ratio, negative. Going back, so we allow 4/3 to be a possible solution. And then we want the ratio to be negative. It means these two are our solutions. So our final answer will be x can be any number less than 0, or it can be at least 4/3.